The next thing I wanted to talk to you about is hypothesis and theories, what that is. There's two major approaches to learning about nature. There's discovery. You kind of just come up with a general conclusion based on your observations. And hypothesis-based science. It's seeing something, trying to figure out why it's that way, and then doing some experiments to figure it out. So I want to talk a little more about the hypothesis base. You're going to learn a lot more about it in lab, so I'm not going to droll on about it. But basically what happens with the scientific method is you make an observation, you come up with a question posed by that, so you come up with some question that you want to answer, you use some prior knowledge, you come up with a hypothesis, which is a if-then statement. It has to be testable. Opinions aren't testable, so that becomes a problem. You design an experiment, you get some data, or you do some analysis, and then you come up with a conclusion. So it sounds complex, but it's really easy. So for instance, let's say you went out to your car this morning and you turned the key and it wouldn't start. So your observation is that your car didn't start. You are going to say, why didn't it start? So you're going to make a question. Why didn't my car start? Maybe it's the battery. So using prior knowledge, you basically said, well, in your brain you said, well, it could be the battery. Maybe you didn't have enough gas. There's a few things that you might be able to access yourself before you have to call a mechanic. But let's say the two things that we're thinking about is battery or gas. Yesterday you filled up the tank, so we can eliminate gas. So what do? You come up with a hypothesis that I think that my car isn't working because the battery might be low. You do an experiment, and the experiment could be a million. You could swap batteries with another car, you could get a jump start, you could just buy a new battery. But let's say you just do the simple one, get a jump start. All of a sudden your car is working. So you get the data that your car is working, and obviously everything's working. So your conclusion is, yes, it was the battery. The battery was the reason why the car didn't start. Now, let's say the car still didn't start. Let's say you even did something extreme and bought a brand new battery. You would basically just pose a new hypothesis. So let's say the battery didn't work. Now you're going to pose a new hypothesis. Well, maybe I need a new starter, or maybe I need something else, and you're going to repeat all of those. So that's just one example, but it could be something even as simple as, why isn't the TV remote working? Why isn't the internet working at my house? And you could come up with all of these same conclusions. So does the hypothesis have to prove anything? No, we still have to go through the whole process of getting the experiment, the data, and things like that. And you're going to learn a lot more about that process later. I've put a little video, the scientific method one. If you open up my PowerPoints at home really big and click on that, you'll see a video that shows the scientific method with plants, and it has a really cool thing. A theory is even more conclusive than a hypothesis. So a theory is a general idea supported by a group of well-supported hypotheses put together, and at this point can't be disproven. So let's look at the scientific method on just a couple of these and see if we can prove it. So for instance, if you were posed this question, does Rogaine really improve hair growth? Well, how would you test it? So my example would be, you could get 100 bald people, 50 of them you give them Rogaine, 50 of them you don't give them Rogaine, call them back after a couple of months and see if one group had more hair growth than the other. You can measure that by taking pictures or counting hair. Hopefully you don't do that, but that's a possibility. Let's do another one. Does the hormone estrogen increase the milk yield in dairy cows? Well, you could do the same sort of thing. 100 cows. I keep using 100, but it could be, usually they say anything above 10 is a pretty good number, but you can give 50 of them estrogen You can give 50 of them a placebo, which is something else. And after a couple of days or weeks, you could start to measure the amount of milk being produced per day. And if the estrogen injected cows are producing more milk, then you can say yes. Let's do an easier one. Which battery lasts longer, Energizer or Duracell? How would you test this one? An example could be that you could have 50 of the same toy, or 10 of the same toy, and put Energizer in it, 10 of the same toy, put Duracell in it, and 10 of them, and you just use a generic brand, and see which one is the best, Energizer or Duracell. Let's do the last one. What foods taste better, Indian food or Chinese food? How can you test that one? I'll give you a second to think about it. All right, well, that one you cannot test. Why can't you test it? Well, because you have to ask a question that could be tested. So your hypothesis has to be able to be tested. And the word taste better is subjective. So if you went to India and said what food tastes better, Chinese or Indian, they might all say Indian. If you went to China, they'd all say Chinese food. So it's not really a well-based experiment. So what you could do is, let's say you took two popular dishes, one from India and one from China, and said which one had the most nutrition. Now that's a good experiment. You could do that. Or which one had the most heat, spicy-wise. That's something you could test. But taste better is subjective, so you can't really do that one. Here were all the characteristics that you needed, or the concepts that you needed from this chapter. I didn't do all the slides as a recording, and I won't. I'll only be doing the big items. So the things that I think you can just read over and do yourself, I'll be skipping those.